The recent COVID, yeah, go ahead, please. Anything you want to say?
No, sir. I think someone joined and their mic was on. Sorry.
Okay. Sorry. Okay, the recent COVID experience itself indicates the importance of timely, reliable results. The enormous pressure each laboratory which were engaged in COVID-19 related research or testing, people are aware. Whether investigating the nature of virus or validating the effectiveness of preventive shots developed, we wanted the results yesterday. So that's the pressure governments were putting or WHO was putting on these labs. And they wanted 100% reliable laboratories. So the whole world was looking at those results. Anything goes wrong and they'll be criticized like anything. To achieve such consistent, timely results, one popular option currently available is implementing ISO 17025 standard. So in this session, we'll briefly see what are the requirements of these standards. A normal course on ISO 17025 goes for 4 or 5 days. So that may not be possible. The purpose of this session is to give an overview of what are the requirements of these standards. So while preparing the course material, I've almost taken extract of whatever is in the standard, because every word in the standard has got a specific meaning. So we may not be able to take it in general terms and then describe it. So it may be difficult to read and understand all the terminology in this 2 hours, but a general idea about what it talks about, what is it we are expected to do, and what benefits it gives the laboratory in producing consistent, reliable results on time. That I think would serve the purpose of this session. So why this standard is important? A large number of organizations rely on laboratories today to perform sampling or calibration or testing activities. So where depending upon that, business decisions are taken. You take even the COVID experience to release a vaccine to the public, the results were awaited. So unless the different stages are crossed, you cannot release it to public. It will become a great risk if it is not properly validated. Laboratory sampling, testing, conformity assessment, they are crucial enabling factors for technology as well as trade businesses. So accreditation or certification to the standard, what way it helps? It promotes confidence in the minds of customer and public. It assures there is impartiality and consistency of laboratory operations. Any results, any reports generated by ISO 17025 certified laboratories, it is accepted by even other countries. So that is the reputation the standard has about a laboratory when it is certified. So we are all very familiar with the ISO 9000 standard, which is for quality management system. It assures the customer whatever the customer requires from any organization will be delivered on time with the required quality what he wants. All the requirements of ISO 9000 also has been incorporated in this standard. So why this standard is named IEC 17025? So normally ISO standards are formulated by technical committee of ISO. Example 9000, 14,000, 31,000, 45, 50,000, all those standards. But this particular standard was jointly developed wherever conformity assessment is involved. ISO doesn't have the expertise, so it joins with International Electrotechnical Commission and jointly develop standards required for conformity assessment. ISO IEC 17025 is one such jointly developed standard. So as I said earlier, this standard or document has been developed in order to provide confidence to the public, customers, legal agencies, etc. Once a lab is certified, it gives a seal of approval. It's like a degree holder from NIT or IIT or Anna University or VAT or some similar reputed institutes. People are aware what sort of background or syllabus or the way periodical testings are conducted before producing a graduate. So any lab certified to ISO 17025 is received, known, perceived by the people that it has got an inbuilt system which takes care of impartiality, it takes care of confidentiality, and it produces always reliable, repeatable, consistent results. So as I said, it also takes care of all the requirements of ISO 9001 already. See, the 2017, these standards are not static. Once the standards are released, almost every 5 to 10 years, they are reviewed, revised. Why the revisions are taking place? Feedback from various users, various customers. These feedbacks are received by the standard developing authority, and they look into it and incorporate whatever relevant thing which requires to be changed in the earlier versions. So the 2017 version brings in certain concepts. One or two examples I will tell. One is the impartiality. Whatever laboratory activities do, it should be free from bias. There should be an objective approach in conducting laboratory activities. This requirement has been added in 2017. Similarly, confidentiality clause. This has been added in 2000, elaborated in 2017. One more very important thing what is added is to address risks and opportunity. Generally, when we say risk, we think it is something dangerous or something creating damage. Each terminology used has got a specific meaning. So what is the meaning of risk as defined in ISO standards is uncertainty to achieve your desired results. Whatever results you have planned, what are the possibility by which you may not be able to achieve? What are the causes? What are the reasons by which you may not be able to achieve the result? That is what is considered as risk here. So what is opportunity? Risk is something which will be causing losses or damages to an organization. Opportunity is using such identified risk. Can you change the situation so that it becomes beneficial to the organization in the long run? For example, one risk we will take delivering results on time. Say customers are placing order for a calibration or a testing, expecting that you to deliver on time. So what are the various possible reasons by which or because of which you may not be able to deliver it on time? One is you have more orders in hand than what you could complete in the specific time, 2 days, 3 days time. What you could complete, you have more orders. That could be one reason. People are absent. There is some strike involved. There could be supply issues. Your equipment was due for calibration. The calibration could not be done on time, or one of your critical calibrating instrument failed, breakdown, and you are waiting for the service provider to come. There can be a number of reasons. You sit together and brainstorm, you will find at least hundreds of reasons. Now, it's not possible to address all the reasons or all the risk what you have identified. So what organization do is they try to prioritize the risk. What are key risk or very important risk which can affect the reputation, which can affect customer satisfaction. So this process is called prioritization of risk. So how it is done? So frequency of occurrence of such causes and the quantum of damage it can create to the customer or to the organization, and the possibility of occurrence, probability of occurrence. Say for example, fire is one thing which can happen in any laboratory, but what is the probability? Almost nil, because you are taking so much care. So probabilities, then you multiply all this, you get a number. Depending upon the higher the number, you call the risk is higher. This is called a risk prioritization process. Of course, there is a specific standard ISO 31000 for risk management itself. So every organization may not have to go for that, may not be possible for it to go. So that is why some elements of that has been taken and incorporated in all the standards which were recently revised, whether it is 9, 14, 45, 50, and 17,025. All these standards are now today having risk management. Idea is it is not sufficient you build a system to serve your customer. Also look for the possibility which can damage your plan, which can create uncertainty in your plan, and try to do something so that the possibility of failures can be minimized. That is a process. So once you prioritize risk as high priority risk, medium priority risk, low priority risk, you may not do any serious action for low priority risk, but only you will keep on monitoring, observing, so that if ever anything happens, you immediately respond to it. But high priority risk, necessarily you have to draw some contingent action plan or mitigation plans so that you are able to eliminate or reduce the risk. So whatever plans you have made, it is still possible to be met without much failures. So what is opportunity? Opportunity is having identified. I'm just for the convenience of discussion, I'm saying. So when you say equipment breakdown can affect your delivery, on-time delivery to customer, the easiest solution is to have one more equipment, but that is the costliest solution. But there may be other alternatives which you have to look into. Train somebody in your own organization to rectify it rather than waiting for some OEM fellow to come from Ahmedabad or Delhi or Noida. Okay, so there may be solutions which are easily manageable and reduce the risk level. So this requirement has come as a new requirement in 2017 version. Okay, so addressing both the risk and opportunities helps you to face the customer situation much better. The entire standard can be told in 40 pages or in one slide, 5 lines. So if you want to talk about it 5 lines or even 4 words, it can say there's a quality expert who brought the quality levels of Japan from the lowest in 1950s to world-class quality. Edward Deming is an American, but his quality principles when he preached in USA, nobody was willing to receive because America was the dominating country in the global economy those days. So he went to Japan. Japanese were in doldrums after Second World War. So they needed some guidance, some support to guide them to take them to world-class quality level. And Deming was one such person who was one of the key persons to bring Japanese quality level to this world-class level. So he proposed 4 terms: plan, do, check, act. Any activity you want to do, any organization you want to run, any process you want to manage, first do the planning activity. Planning is planning for equipment, planning for people, planning for process, planning for procedures. So any facilities, environment, all the aspects you plan well. Also, well planned is half done. That's how people say. Then do it. Do it. It is not start doing it just like what you are doing. It is to follow what has been written down in your planning document. No deviation at all. Completely relying on in your procedures, SOP, whatever has been made as the requirement for your organization, you'll exactly follow as given in the document. So check is nothing but check the results periodically. Don't wait for the end result. So end product, when you check, it is called inspection. You'll only find out whether it is okay or not okay. You cannot do anything about the improvements. So you have to only reject the defective product. But here the check means at different stages, process checks, in between quality control checks, in between process checks. So you will check whether at different stages, intermediate stages, whatever results you have planned, is it coming? If it is not coming, do, means take a corrective action. So this is what Deming proposed. Same thing is stated here. Say what you do. Write down all the procedures, your technical specification, SOPs, etc. Do what you say. Do your activities as said in your documents. Record what you do. Whatever data you generate in the process of testing or calibration, record all the relevant data properly. Check the difference. Are the values reflecting what you have planned or what you are anticipating or expecting? In case there are differences, act on the difference. So simply this is what is written in the standard, but in so many pages, in so much detail, so that everybody uniformly understand and implements the requirements. So if you want to say it in one line also, you can say do right thing first time, every time to achieve consistent quality. Probably this is one slide which completely describes the entire standard or all the requirements of ISO 17025 which you require to implement for you to be certified or accredited to 17025. So I'll briefly touch upon each of these clauses. There are 8 major clauses available in the standard 1 to 8, 1, 2, 3, 4, 5, 6, 7, 8. But here I have left out 1, 2, 3 because they are general in nature. They do not describe any particular specific requirements what a laboratory has to handle. They talk about some references, they talk about the scope of application, etc. So the requirements what a laboratory has to do are described only in 4, 5, 6, 7, 8. Okay, each class what is describing in their subclasses, I'll just touch upon. So 4 is general requirements. It talks about 4.1 impartiality, how the laboratory people have to be impartial while carrying out their testing or calibration. Then 4.2 is confidentiality, how to maintain confidentiality, because you are getting lot of data information from customers. Like you take even the COVID examples, different laboratories give their samples, whatever vaccine they have developed, they are giving it to you for testing. So if anything leaks from your laboratory to the competitor, then that's all finished, because every product what they generate, they have a right to patent it for so many years depending upon the product. Oh, means for producing and selling, they are the sole authority for so many years. That protection is lost, business interest is lost when you allow some information is lost. That is why these classes become important. Then 5 talks about structural requirements. What is structural requirement? So how the organization is organized to take care of or carrying out activities. One is it is legal status, whether it is a legal body, like have you got all the licenses, consent orders, fire clearance, sanitation clearances. So then are you having mechanisms to meet all the legal requirements? For example, if you have a chimney, do you have plans to monitor the emissions periodically? Do you have systems to ensure it is well within the permissible limits? So all these legal requirements, they are addressed here. Second, the organization structure of your laboratory. So how it is with respect to the overall organization. For example, NIT-DE has a laboratory, set of laboratories. So how these laboratories are positioned in relation to the total NIT organization. So this organization structure. Then who are the people employed? What are their designations? So put a organization chart, define their duties, responsibility, authority, accountability. Everything is clearly written down so that there is no, lack of clarity, confusion later. So all these aspects are addressed in structural requirements. Then comes resources. Resources, to run a laboratory, you require people, you require facilities. Facilities are water supply or drainage system or compressed air supply, then environmental conditions, air conditioning of your laboratory. If it is a clean lab, maintaining cleanliness of the laboratory. So you know what are the environmental requirements of a laboratory. Then equipment, the testing or calibrating equipment or instruments, measuring instruments, all those are covered under equipment. Then metrological traceability. Wherever you have a measurement, wherever you have a measurement uncertainty, which is likely to affect your final results of calibration or results of testing, they all require to be periodically calibrated. People are familiar already. Okay, the calibration has to ensure linkage to international standard. So you have to have inbuilt a system by which whatever instruments, equipments you have, the calibration of which should demonstrate the linkage to international standards. So that is what is called as metrological traceability. Then externally provided products and services. In spite of you building a good laboratory, all the requirements cannot be met by your own resources. Sometimes you have to fall upon some service provider or some outsourcing. For example, calibration of your equipment and instruments, you require to depend on OEMs or some other laboratory or some other calibration centers. So how to consider them for your organization? What are the process by which you will evaluate them, validate them, and take them into consideration for using them, engaging them, and periodically ensure that they are keeping up their standard, they don't deteriorate. All those processes are described here. 7 is a process requirement. It talks about various processes. It is heart of the system. Very important clause is 7. So one is review of request, tender, and contracts. Whatever customer asks you, make a request. Have we understood the request clearly? So whatever he asks, we may not be able to perform. So or we may take a deviation. How to talk to the customer, resolve the differences, finally agree upon what you will carry out, so that when customer is given the report, he is happy that whatever his agreed requirements are met. Second is you have lot of reference standard, reference sample, reference data. These are all used for testing or calibration. So how do you select, verify, validate such reference standards, methods, and tools? If there are international, national standards, published standards, it's easy to adopt by both customer and the laboratory. In case it is not there, you will choose what is available in the market or customer supplied one or what you develop from your laboratory. But agreeing upon this is an essential requirement, so that is addressed here. 7.3 is sampling. In case you are doing testing, you may not be able to take the entire material supplied by customer for testing. You may take a sample. So the sampling plan, sampling procedures, such details are addressed there. Then 7.4 is handling of test or calibration item. From the moment you receive sample or instrument for calibration or testing, how it is received, stored, preserved, transported, handled while doing testing, all that is addressed here. Technical records, nothing but data generated, processing of data, storing information, ensuring confidentiality, all those is addressed here. Evaluation of measurement uncertainty. So any measurement has got its own variability. So how it is going to affect final result. So the measurement of uncertainty has to be evaluated. The process is described here. Assuring the validity of result is described in 7.7. Where it is not just the outcome of an equipment is just like that produced for the customer. So there is a process of reviewing the result by a second level person. Then there is an approval by a third level person before it is released to customer. Reporting of the result is nothing but releasing the test report. Complaints. In spite of best efforts, still customer may have some issues, deviations from what he expected. Maybe result is not received on time, or the report has got some deviations. So there can be many issues from customer viewpoint. So you have to have a demonstrable system where you are able to receive feedback, record, acknowledge the complaints, and then evaluate the complaint, analyze the complaint, provide a solution within a reasonable time. The entire complaint management process is described in 7.9. 7.10 is non-conforming work. So you have set of instructions, SOPs, procedure, etc. So when you are carrying out work, there can be some variation, deliberate or without you knowing something can deviate from the return down procedures or the standards requirement. Such deviations are captured, analyzed whether it is going to affect the final results. If it is going to affect, then investigate further, implement the corrective action so that your process is set right. Then the control of data information management. We have talked about confidentiality, how to manage data, because many lab testing centers may not have their own IT. IT will be handled in any organization by a separate group. It's not sufficient that you keep information confidential. The IT in charges, how well they have their own access control systems or firewall systems to ensure data are kept managed properly. These are addressed in 7 process requirement. 8 is clearly on systems related to standard ISO 17025. So it has got 2 options, options A, options B. It doesn't matter. If you are already certified to ISO 9001, you can take option B. So you don't have to repeat documentation aspects. All other aspects are relevant. If you are not certified already to 9001, your first time you are going for 17025, all the requirements of the standards are applicable to you. So 8.2 is management system documentation. So to implement the standard, what are the various documents you have to? Okay, so all the documentation requirements are defined here. In fact, there is a slide which lists out various mandatory documents required for implementing the system. The next 8.3 is control of management system documents. So as they are key documents for implementation of the system, there has to be a control, like who will prepare, who will review, who will approve, who will issue the document, who will update it periodically as and when changes are taking place, either in the standards or calibration reference standards or any other thing. If changes are happening periodically, these documents also require to be changed and reissued to people, and obsolete documents have to be withdrawn and destroyed. So all those are addressed here. Then 8.4 is control of records. How do you manage the records? Generation, keeping it with someone called custodian, how long the records have to be kept, period of retention, how to dispose the record or the obsolete record or unwanted records, how to properly dispose, all that is discussed in 8.4. 8.5, as we discussed earlier, risk management. 8.6 is improvement. The standard also looks for not only establishing, maintaining systems, also bringing improvement. What is improvement? Improvement is over a period reducing your cycle time, bringing automation, or reducing errors, reducing NCs, increasing reliability, increasing customer satisfaction. So we are aware what is improvement, but every year, every period, we are supposed to work for certain improvement aspects or opportunities and then bring improvement in the overall system. Then corrective action, whatever we talked about NC in the process. Similarly, any system deviation found out during internal audit or external audits, so they all will have to be supported with the corrective action. Corrective action is setting right the system. Then 8.8 is internal audits. Audits are two types. One is internal audit, the other one is external audit. Internal audit is done by your own people, so that you don't spend resources by spending money, but your own trained people, qualified people, you are using them. Audit is nothing but to check whether all the processes are being carried out as planned. Are there any deviation? So when it is done using internal resources, it is called internal audit. Though there is no time specified, periodicity specified in the standard, see, organizations normally do at least once in 6 months or once in 3 months. More as frequently as you do, yearly you will find the deviations and correct it so that your system comes back to its normal expected way. So if you are doing it once in a year, sometime the second month deviation happens, you are finding it out after 10 months. So that is why, more frequent internal audits are always reliable, better. Okay. So as I said, 1, 2, 3 are not very key sections for implementation. They are not describing any requirement. So the class 1 talks about scope. Scope is what is the applicability of the standard. For example, you may have different labs. You may have a thermal lab, you may have a hydraulic lab, you may have a water lab, you may have a coal lab, you may have a calibration center. So when you go for certification, you may choose to go only for a limited facilities. For example, calibration center alone, I'll go for ISO 17025. So if you are doing it, should be clearly defined that I'm targeting for certification only calibration center. Though I have other facilities, they are not calibrated. So when you are publishing in your letterhead or website, it should be clearly brought out. Though you are certified to ISO 17025, you have been certified only to a particular facility. So defining that applicability is what scope. The second thing is, as I said, for various people like a customer, regulatory authority, accreditation body, this certification becomes like I said, no, a graduate from NIT, IIT, or VIT. So they are known for their own quality. People will understand what sort of input they have got, what sort of grind they have undergone in their academic curriculum. So like that, people by looking at the certification easily will understand this is a reliable laboratory. So for that also it is used. I also mentioned in the introductory slide that even other countries accept ISO 17025 lab results as acceptable results. No questions are asked. Second, normative references. In order to implement this, you also will take reference of some more ISO standards. It's for vocabulary or some understanding basic and general concepts. So general principles. So you take support of ISO Guide 99 and ISO 17000. So the terms used, as I said, every term used has got a specific meaning. We may not be able to use our general meaning here. So it defines it in a particular way. That's how we have to interpret. We are supposed to interpret. So all these terms and definitions are given in the same Guide 99 as well as 17,000, which we have to take while implementing the standards in any organization. So now we'll come back to the applicable requirements from 4 to 8. So as I said, I have reproduced exactly from the standard. So it looks quite lengthy and difficult to understand, but we'll take essential meaning of it. That should be sufficient. Yeah. So 4.1, as we said earlier, it talks about impartiality. It is defined in ISO 17025 in the terms and definition. If you look at it, is presence of objectivity. Whatever work you perform, you should perform with objectivity in mind. There should not be any bias. This means that the outcome or result of an activity is not compromised by any situation. It is not influenced by any situation or by action of a person. So all the laboratory activities shall be done impartially and should have appropriate procedures in place to ensure impartiality. See, one example could be a person is doing a calibration, okay, for a customer. In case some of his family members are working for that customer, there may be a possibility of him getting influenced and making always ahead of time performance for that particular customer. I'm just saying a situation. So how do you avoid? So there will be a code of conduct for laboratory personnel. So whichever customer they are handling, they will give a declaration. Me or my family members do not have any family members. I'm just saying, for example, it can be friends, it can be anybody else also, relatives also. So we have no relation with this company. A declaration may have to be given. So idea is others should not suffer just because this person gives priority for a particular known person or a person of importance in his opinion. So it is not sufficient you have operational SOP. It also has to be committed by the top management. What is top management commitment? Even in the process of finding out any impartiality is there, he must play a personal role. The top person of the laboratory also has to join and investigate periodically to find out and ensure impartiality is there in the organization. Nobody acts on any influence or with some bias. So like any other risk identification management, here also, what are the possibilities somebody can be influenced? So can somebody be bribed? I'm just saying it's a possibility to give a wrong results. It can happen in commercial establishment. People here who are attending the course may be from institutions. So you may not have such a big commercial interest. You take the world level laboratories. We are still talking Wuhan laboratory. Nobody believes Wuhan laboratory people have got integrity. The information is not coming out what has happened inside. So commercial interests are there. You test some other pharmaceutical company's product and say it is not fit. So you can finish the company off in one such a decision. So enormous pressure will be there on laboratories of such a scale, such situation that ensuring impartiality can become a big task. May not be a big task in your type of organizational laboratories. Second, confidentiality. We know what it is. We have also just mentioned about confidentiality in the introductory slide itself. So we must ensure customer is able to legally enforce your commitment. When you are giving commitment to the customer that I'll protect your information, if anything leaks, the customer should be in a position to sue you and get compensation and even go to the extent of banning your laboratory. To that extent, the provisions have to be made. It is so sensitive because when you are in a research laboratory handling different, research organization sample, this becomes very, very important. So in case you want to use any of the customer information in any public domain, for example, periodically you may be publishing papers or you may be presenting in some conference. So you may say your experience related to testing of a particular customer sample or a product. So unless you get his permission, clearance for doing it, you cannot share it in public domain. This is a requirement of the standard. So every information given by the customer is considered as proprietary, his own information. You can use it only for testing calibration purposes and nothing else. Even if you are using it, you are supposed to forget it just after testing. You cannot retain it and communicate to anybody else. So even sometime, for example, I'm just saying a situation, CBA writes your laboratory, they want to take all the information. So at that time, you may not be able to protest and say, I require to get the customer's permission. So there are legal authorities who have so much authority power that they can seize all your paper, all your data without getting your concurrence or permission or approval or any customer's concurrence or approval or permission. So in such cases, no other go, you may have to pass on the information. And if that organization, the legal authorities permit you, just after the event, you can communicate to the customer. So such and such data has been taken over by so and so legal authority on such and such day. You can communicate to the customer. If that agency says even that should not be done, you have to keep quiet. That's the legal requirement of the country. You have no other alternative. But for that situation, you cannot part with, you cannot share, you cannot publish any of the customer information. Then we will come to structural requirement. As we mentioned, it is legal aspect. So as I said, the legal could be many things. Like the licenses, whatever you require to get, or consent orders, pollution control board. If you are a medical laboratory, then biomedical waste rules you require to follow. You have to get clearance from pollution control board, fire clearance, sanitation clearance, depending upon the size of the laboratory. So sometimes you may have to periodically submit returns to certain authority. If you are using, say, poison material like sodium cyanide, potassium cyanide, if you are using, it is covered under Poison Act. So you require to keep it in a specific person's custody. How much quantity you procured, how much you used, which customer, which testing you used, all that you have to submit return to the authorities periodically. So there are such returns requirements. So providing for all these legal requirements is considered as a part of the structural requirement. Then second is an identified person or set of persons have to be there for the laboratory who will be responsible for all the happenings in the laboratory. The process owner, the laboratory in charge, he can be a technical manager or quality manager. You can give any designation you want, but they are responsible for a set of activities defined in your organization chart. This has to be necessarily done. Then also define what is the range of activities for which you have been certified. This we have discussed already. That also has to be there. Then whatever activities you do, it has to be meeting the requirements of this standard, meeting the requirements of this customer. Over and above that, if you have got your own organization requirement, that also has to be met, and any legal statutory requirements. So whatever your procedures you are writing, it should cover these four type of requirements. One is the requirements of the standard, requirements of the customer, your own organization requirement, and legal requirements as well as accreditation body requirement. All that have to be ensured in your procedures. So define the organization structure and how it is related to the parent organization. Specify responsibility, authority, accountability, and duties. So even relation between the technical assistant and the technical manager, quality manager, all that have to be very clearly brought out in the chart and document it as much as possible so that it removes ambiguity. It brings a very clear documentation on who will do what. And when something happens, who is the person responsible for that? All that is brought out clearly. So this one requirement earlier it was there. Now the name is removed. This is called a management representative or management appointee, or the person who has got the responsibility and authority of implementing the standard in the company. See, normally the top man of the laboratory quality manager is responsible for implementation of the standard. But still, they can nominate a person, single person, who will be called the earlier management representative. Now the terminology is removed in all the standard, ISO 9, 14, 45, 50, all it is removed. But still, the requirement is there. What are his duties? Implementation, maintenance, and improvement of the management system means implementing ISO 17025 in the organization, maintaining it without violating, without deviating, how to maintain it. Improvement, bringing reasonable improvement periodically so that cycle time is reduced, quality is improved, customer satisfaction is improved. So all that is to be done by this person. Also, identification of deviation from the management system as well as the procedure. While performing your activities, are you deviating anywhere from your written down procedures, including the documentation requirements? So then initiation of actions means whenever deviation is found, what we do the correction. Correction means setting right the situation then and there immediately. Okay. Then corrective action. So how to prevent a recurrence of such things in the future? For example, error takes place in calibration. The person who is doing the calibration he is not knowledgeable on interpreting certain reference standard. He makes a mistake. Okay, so he produces a wrong report. What is the correction? Do the interpretation correctly, produce a correct valid report, send it to the customer. This is the correction. This is one time done. So what is the corrective action? Why this error has happened? You do a root cause analysis. So why it has happened? Because the person who did the work did not know about it. Why he did not know? Either he was not taught in the training or he slept during training. One could be reason. So what is the solution? Take him for a retraining, train him, ensure he has learned, and then put him back to the job. So this is a simple reason I have taken. So for every deviation, there can be many reasons. You will analyze into that, and root cause you will identify and implement a corrective action. So any deviation, you always will have two sides. One is correction, the other one is corrective action. Corrective action is to prevent a recurrence of that. So reporting laboratory management on the performance of the management system and need for improvement. So periodically updating your lab manager, QA manager, as well as the top management. Top management comes to know through a process called management review. We are going to discuss at the end. Management review happens, many organizations have it once in 6 months. You can have it more frequently also, depending upon management's interest on improving your system. So where you will update all the happenings of the organization with a single theme, whether systems are under control or anything going beyond our control. So plus what are the support you require from management. These are all reviewed in management. We'll see the detail later. So the process is done in order to ensure effectiveness of the laboratory activities is maintained. So these are the tasks, and you will identify a person for that. Resource requirement, as we discussed, 5 type of resources. One is people. People can be for 2 type. One is internal resources, the other one is external resources. Internal resources, people whom we are using inside the laboratory for doing testing or maintaining laboratory, including the sweeper who cleans your laboratory and maintains your laboratory environment condition. If she or he is not aware about the dust level permitted, then if she uses a broom instead of a vacuum cleaner, she can create damage. So who are all available in the laboratory, performing, contributing to the testing calibration system, they are internal people. External people, you are outsourcing certain services, maybe for calibration, maybe for testing, maybe for some other purpose. So all those external people also, if they are affecting your calibration result, you have to define the competency. So what is competency? Competency is a combination of educational qualification, technical qualification, training what they have to undergo, skill what they have to possess, experience what should the people have. The combination of all this is considered as competency. So how do you do this competency management? For all the roles you have in the laboratory, as I told, he may be cleaning and keeping the laboratory in good condition. From that person onwards, a person who designs your processes, writes down your SOP, approves your SOP, who brings a new testing procedures, the chief of laboratory, maybe technical manager. So all these people list down each role in the laboratory and define what are the competency requirement. Write down what should be the technical qualification, what should be educational qualification, what are the training you should have undergone. What is technical qualification? For example, anybody doing NIT testing. So you should have a ASNT qualification level 1, level 2, level 3, depending upon what type of role he plays. Level 2 is permitted to do the testing. Level 3 will be the approving person, chief of any NDT system. Okay, so this is a technical qualification. Similarly, if you engage a welder, okay, calibration lab may not engage a welder, but welder requires a qualification once in 2 years. Okay, so training, because anybody from college may not be able to perform your activities. So he requires to be given some input on what this laboratory does, different process of testing and calibration. Each of the processes, you will give training through a competent person. It may be the equipment supplier or your own trained persons available in your laboratory. So that training he must have attended. Skills are required for certain type of skill-based jobs, and experience. Okay. Okay. So whenever you employ people, you must ensure people have the required competence. and you must communicate to every one of the people employed what are their duties, responsibilities, authorities as defined in your organization chart. So this is not from the standard. This I have just consolidated competency management. Document each key laboratory activity. Document the competence requirement for each of the role available in the lab. Document the procedure. Procedure is how will you identify, how will you define, how will you decide the course of bringing in competency to a person. All that will be training procedures. Review personal appointment. Is your present recruitment process permits you to accommodate all these competency requirements. Say, for example, some big organization, you come to even my own organization, BHEL. Recruitment will be only diploma holders in mechanical, electrical, civil, graduates in civil, mechanical, electrical. With such person, you cannot run a laboratory. So laboratory requires 1, 2, 3, 4 specific skills. So whether you are putting it in the recruitment requirement itself, a person with such qualification only is required for me. So unless it is put, you require to do a lot of homework for you to develop the persons with right competency. Establish a training program. It is to specific need of the laboratory, you require to have training program. Also a training program on ISO 17025 and updations to changes what is happening periodically. You also have to have a program for that. Training record, not only whatever training you conduct in your organization, also whatever training he has undergone in the past in his earlier organizations, entire records will be kept, because competency record will have to be maintained till that person dies or till that person leaves your organization. So entire horoscope will remain with you till he leaves or till he dies. Evaluate and assign a competency level. So level, as I said, no, for NDT you have level 1, level 2, level 3, even for other level, for example, calibration. Level 1 person may be just having adequate competency to perform a calibration. Whereas a level 4 person will be able to even bring a new calibration procedure, automate the calibration device, or bring in new systems. So that person, the level 4 person, will have long experience, you may have more knowledge, you may have more exposure. So you will define this also, you will have a skill matrix. So what are the aspect, for example, technical knowledge about a calibration equipment. So if he has adequate knowledge, you may rate him as level 1. So about one particular instrument only he knows. So you will define as level 1. A person who can do calibration in say 5 or 6 equipments available in a laboratory, or all equipments available in a laboratory, you may name him as level 2. And level 4 will be given to a person who has other than what you have. He is familiar, he is experienced with the handling similar type of calibration equipment what you don't have. He has worked in some other lab, or he has been trained in some other lab also. So depending upon the competency what each individual possesses, you will classify them in different levels also. Monitor personal competence. It is not sufficient you place with required competence people. Ensure they possess the competence on a continued basis. Before you engage them in a job, ensure they have the competence, then only you have to engage. So one question can come always, in school debates. Whatever you have learned, it remains with you, it doesn't get lost. That's how the debates we have spoken. So why should you monitor personal competence? There are certain skills required which depends on your hand movement, which depends on your eyes. For example, looking at X-ray, NDT technician. So if your eyesight, today digital X-rays have come, but still his eyesight becomes important. Color blindness become important. Of course, you don't become colorblind later. If you are colorblind in the beginning, you will remain colorblind till the end. But color blindness can come later if some nervous issue comes to a person. So similarly, if a person is engaged in handling pneumatic equipments, he can get into musculoskeletal disorders. So his hand movements can get affected when he becomes age 50 plus. So that is why welders, that is why they are periodically validated. Though by experience they should become better welders, still they have to undergo, because coordination of eye and hand movement is involved in a welding process. So facilities and environmental conditions. Facilities, as I said, it talks about air supply, water supply, gases, what you require, environment, like your cleanliness, temperature, humidity, all those systems, what is supplying. All these you have to define in a document. each aspect, how we are going to do it, how it is going to be monitored, how it is going to be controlled, who is the person responsible. In case a deviation takes place, what corrective action will be done. All that have to be written down and continuously monitored. Records also have to be kept. Equipment is nothing but the main equipment and auxiliaries what is required for you to do the testing and calibration. Examples could be the main equipment instrument. Apart from that, measuring instruments, software, measurement standards like your calibration standard blocks, etc. Reference material, which say for example ultrasonic testing, always you have a reference blocks which you first do it before you do the actual ultrasonic measurement. Reference data which are available as standards for you to refer. Then reagents in a chemical or pharmaceutical laboratory, consumables, auxiliary apparatus. So all these can have variability in the, introduce variability in the testing process. So for all the things what we just mentioned, you require to define what are the requirements. Define means it's not only defining, writing down each equipment, the technical specification you will write down. Also, where from you will procure, you will also decide that. Vendors you will decide. You will identify vendors, you will have a evaluation process, you finalize the vendor and approve the vendors, keep a list of vendors. So anytime you require a software, you will go only to a set of 3 vendors, and I'm saying 3 as example, set of few vendors who are already gone through the approval process of your organization. Because every time you get from a new person, that can introduce variability in your testing system. So sometimes you may do your activity beyond your premises also. For example, as I was mentioning, BHEL does a lot of activity of manufacturing in units, Trichy. But when the equipments are assembled, sometimes you have to go and test it in the site when it is starting performing performance test. So at that time, you will take instruments from here. But you must ensure whatever environmental requirement and other requirements are met at a site also. Even when you are moving out of your permanent location, you must ensure all the requirements are met. You also have to have a procedure about handling, transport, preservation, use of all these equipments, instruments, software, etc. So if they are not handled properly, damage, deterioration can take place. So you have to have a procedure for transportation, handling, using, preserving. All that have to be there. Similarly, when something is taken for preventive maintenance or for any service by the OEMs, so when it comes back to laboratory for service, ensure they are in good shape. You may have to do some preliminary checks, have a dummy run or a test run to ensure they are performing as per the plan, as per the requirement before you start doing the actual work. Similarly, evaluating process capability of your equipments, instrument periodically and keeping records. Choosing appropriate equipment for the job with the right precision, right accuracy, and you have specified measurement of uncertainty either in the standard or by the customer. So when you select an instrument or testing equipment, ensure they are all having within this specified parameters. If you choose a wrong equipment, results can go wrong. So similarly, calibration is a standard requirement where all the instruments, measuring instruments or gauges can affect the test result or calibration result. All such instruments, gauges have to be calibrated. So it should not be a general understanding. Any instrument available in the laboratory has to be calibrated, need not. For example, you may have a water flow meter, which just measures the consumption of water by the laboratory or your testing center. So that is to regulate water consumption. It is to report to pollution control. It doesn't have anything to do with your testing or reporting. But at the same time, a thermometer, what is available to monitor the temperature of your laboratory or calibration center, that requires to be calibrated because calibration center has a specification 20 degrees plus or minus 0.2 degrees. So any variation can affect the calibration result. So the thermometer used for measuring temperature of a room in a laboratory requires to be calibrated. So what will you do? You will list down all the instruments, gauges which have to be periodically calibrated. Identify whether it is going to affect your test result or calibration result. The answer is yes, they have to be put under calibration program. So what is a calibration program? All these identified measurement gauges, instruments, you will generate a master list. So the master list can be in Excel form or in hard copy, whatever form you want. It will give the entire horoscope of all these instrument and gauges. So you will have a unique identification of these gauges or instruments, from whom you have procured this, when it was procured for the first time into the laboratory, when it was put into service. So all the past calibration details, when it was due, when it was done, and all the results of past calibration at the end of each calibration, whether it was required to be adjusted or made some adjustment for it to become fit, or it had retained the fitness and it was just calibrated and sent back to you for further use. So what is next date due for calibration? So entire history of one particular gauge will be there. So in one line. So like that, for all the instruments, you will maintain a master calibration chart or calibration program. So this will in one sheet, one look, it will give overview of your calibration health of the laboratory. So this you are familiar. Any equipment or instrument which requires calibration indicate the status on its face itself. Like if it is instrument, put a sticker. If it is an equipment, put a label or something hung on that in a particular prominent location, so that when you want to use that, just by looking at the tag or the label, you will come to know, yes, it has a valid calibration status. Then you can put into use. You can also go on to look at the calibration chart and do it, but every time going into computer or going to one location and seeing the calibration status may not be practicable. But putting a label or a sticker is easy to do it. Similarly, any equipment which is damaged, mishandled, or overloaded at any particular point of time, please isolate, put a proper label on that, ensure it is not put into use in future unless it is set right and checked for its validity and brought back into the system. Similarly, when you run a calibration equipment, it may call for intermediate checks as per the procedure given by the equipment or instrument supplier. Please list it out in your SOP and ensure they are all done and records are kept properly. Similarly, the reference data, reference value, reference standards, whatever you use, ensure they are all properly updated as per the latest requirement and they are available. So for every activity, you will have some identified person, identified periodicity, under conformance, yes, it has gone through the cycle of check and balance and records are available. So idea is all that is to prevent any harm, damage to the system, equipment, reference standard, so that the results produced is reliable without any error. Traceability, we have talked about it. You have to establish and maintain metrological traceability of all the measuring instruments and gauges by an documented, unbroken chain of calibrations. See, wherever it is contributing to measurement of uncertainty, means it is related to the final result, final results of testing, final results of calibration, you have to ensure unbroken chain of calibration, means linkage to the international standard. See, one easiest thing what people do today is calibrate all your instruments at a NABL accredited laboratory. NABL is National Accreditation Board for Laboratories in India. They are the authorities for implementing ISO 17025 in our country. So they are the agency for giving ISO certificate, 17025 certificate to all labs and testing centers. So when you do the calibration at NABL laboratory, nobody will ask about traceability to you, because when they give certification to that laboratory, they ensure all their standards, calibration blocks, reference standards are all provided with the linkage, unbroken linkage to international standards. In case you are doing calibration with other than NABL accredited laboratories, it is your responsibility to ensure the reference standard used by your external service provider has a linkage to international standard. All the related data, he might have done with say national level, national physical laboratory or national aeronautical laboratory somewhere. So their calibration detail and the NPL NIL's data with the Paris standard or London standard, all those records you are supposed to get it and store it and show it, demonstrate it. Then only it will ensure that you have maintained an unbroken chain of calibration related to international standard. So if it is not there, then you are not sure of linkage to international standard. So that is why the most convenient thing is calibrate all your instruments gauges, preferably with a NABL approved laboratory. This requires to be done only for instruments gauges which require traceability to be maintained. As I said, for the water flow meter, you need not engage a NABL approved laboratory. Maybe for a thermometer measuring room temperature, you require to do that. So we talked about external service providers. You have to have a system procedure, set up procedure. How will I identify the service provider? How will you evaluate and approve them? How will I monitor the vendor performance over a period, every 6 months, every year, or every order they execute? I will rate them on quality, delivery, responsiveness, their competency. You may have several parameters. Define the parameters. How will you give scores to them? What is the maximum score? What is the overall score? Then classify them also. Means people scoring above 90, they'll be called A class vendors. So people scoring 80 to 90, B class vendors, 70 to 80, C class vendors. Anybody below 70, D class vendors. I will not engage with anybody in D class category. They'll be removed from a list. So then every year you will have an improvement target, how to promote a C class vendor to B class. So what are his deficiencies, where he is failing, how will I give feedback, how will I give training to him, how will I elevate him to a next level. So this will be one of the tasks. So you will engage for all your critical activities, critical requirements, only A class vendor. So it is, I'm just saying, these are all can be put down in your procedures. So how do you locate them, identify them? How do you evaluate them? How do you select them? How do you maintain a approved vendor list? How do you monitor their performance based on quality, delivery, responsiveness, competency, etc.? And based on their performance, you rank them, remove them from the list in case they are not satisfactorily performing. Try to elevate their performance by providing training, feedback, continuous working with them. Okay, so when you engage people, all the external service providers also have to meet the requirements defined. Like internal people, they also should have competence. Their equipment also should be qualified equipment meeting your requirement. Their environment also has to be as per your defined requirements. Ensure the standard requirements defined by you, defined by the standard, are met by the service providers also. So now we come to the process. So as I said, first, do we understand what the customer communicates to us clearly? So if he gives an instrument and says calibrate and give the calibration report, then you cannot just like that take that order and start calibrating. So once you finish calibrating and then sending to him, he may say, I didn't want against this standard, I wanted calibration for the other standard. That is what other service providers were doing. So this can always create heartburns and issues and dissatisfaction to customer. So normally laboratories have a checklist, a clear checklist. What are the information I am looking for from a customer when he places an order? So if some information is not providing, you please reach out to him, get those information, get it filled up, so that when you start taking up, you are very clear about what is that you are going to do. So if he himself, the customer himself gives that, fine. If he is not giving, please seek for information and get it. Sometimes you may have deviation. What he is asking, what capability you possess, there may be differences. What you possess may be adequate. Then you talk to the customer, sort it out, and what is agreed between both of you, record it, communicate the recorded agreement to customer back again, so that it is understood that this is the version we are going to perform finally. So whatever differences we sort out also, finally it is documented, conveyed to customer, so that the understanding by both agencies are clear. Then you please evaluate whatever work asked from you. Do you have the capability to do it? Is it within your range? If it is not within your range, then you cannot accept an order and process. So wherever you are using external service provider, get the customer concurrence before itself. That for such and such purpose, I'll be using this particular vendor. Is it okay for you? Sometimes the customer will say, in case you are going further, please use our preferred vendors. So they may not be in your list. Then it is up to you to look at those vendors, evaluate them, and include in your list, and then engage them. So engaging the third party is always a complicated thing. You may have one list, customer will have another list. If they are not matching, so you have to go by what customer wants. No, you cannot force your customer. You can talk to your customer that I have an approval process by which I have selected all these vendors. They have been performing well. Can you accept? If customer accepts, fine. Otherwise, if he gives a set of vendors, you require to go through the evaluation process and then put them in your list and then do the work. Then whatever procedures, reference standards, methods you select, also you have to keep a customer informed so that he is convinced that it meets his requirement. Sometimes a customer will suggest a method. It may not be appropriate for carrying out that activity. You have to politely inform him it is not meeting the requirement. These are the alternatives. What do you say? So convince him for a better alternative, correct method, and then do the activity. In case he insists, so I know better about what I want, you please do that. Then always you can do the work. But what will you do? I am not owning the result what I am delivering you because you are insisting on your own method. So I may not be able to give a guarantee or assurance on result what I am doing it. Similarly, how the decisions will be given. For example, calibration result you are giving, it is meeting the requirement, it is fit for use. So which standard you are going to use, the decision rule, which reference standard you are going to adopt, that must be clear between both parties, customer and your laboratory. So all these will have to be written down in under 7.1. You have to write down the procedure, customer relation management. You'll write down all the details in the procedure, identify who is the person responsible for each and every activity, what is listed out in the procedure, and in case of deviation, where it will be taken, how it will be resolved, how the communication to customer will be taken, and who is responsible for that. All that will be addressed in the procedure. Okay, validation, verification, reference methods. Okay, so you shall always use appropriate method. If it is mentioned in the reference standards, it's easy to adopt. In case it is not there, you have to adopt it from what is available in the market or in the published standards, closed standards or manuals. So you require to take and ensure only relevant, acceptable things are used. So when customer does not specify what is the reference you have to use or method you have to use, then if you have your own method, you can propose to the customer. Or if you also do not have, then what is generally available published standards? It can be international or regional or national. You can adopt it. But whatever you adopt, to keep your customer informed. Only after his approval, you must implement it in your laboratory for testing. So whatever method you use or you develop, they must be proven before putting into actual usage. You must try it out in a prototype or whatever process you require to do it, and then only you have to do it. Without proving, if you are taking it, it can give erroneous result and customer can suffer. So this I said, it is a simple thing, how to handle transport, use, preserve, depending upon the material what you receive from customer. You require to have a return down procedure and then implement it with the duties, responsibilities, and accountability. Also, identification of all the samples or instruments received from customer. There should not be mix-ups taking place. So there should be a very clear, unambiguous identification system in place, so that any point of time you are able to relate it to the test report, and anybody by looking at the sample will be able to know from which customer, what date, what item, what purpose it was received. Then this is another key element, measurement of uncertainty. Always say that the standard prescribes what is the permissible measurement of uncertainty levels or the customer specifies. So you identify what are the things which can contribute to measurement of uncertainty without leaving anything. You have to identify, then evaluate each what it can contribute. If you are doing testing activity, sometimes the testing standard may not call for a rigorous evaluation of measurement of uncertainty. So it will be suffice if you are doing some rough estimation of it. So depending upon what standard requires, you can go for detailed measurement or just make a rough measurement, rough estimation, sorry. So ensuring validity of results. After all these activities, when you publish results, so how do you ensure the results are valid? So how it has taken care of all the requirements, all the parameters specified by the customer, your own written down documents, your SOPs, your equipment suppliers procedure. So how do you ensure all that has been met before it is delivered to customer? Okay. So always the results are reported by the performer, and there is a next level who is supposed to be the reviewer. Reviewer task is he goes through and checks whether all the steps mentioned in the procedures have been followed, all the references used have been correct and appropriate, and they are all valid. All the calibration status of instruments gauges used are valid. Then he declares my review. After my review, the results are acceptable. Then there is some authority like a quality manager who approves the results and then releases to the customer. So these are stages which are defined in your procedures, and rigorously every time it goes through. Okay, so what are the checks or monitoring you do? One is use of reference material or quality control of materials, whether it has been done properly. Use of alternative instrumentation that has been calibrated to provide a traceable result. Functional checks of measuring and testing equipment. Use of check or working standards with control charts wherever applicable. Intermediate checks of measuring equipment as envisaged in the equipment suppliers manuals. Replicate test or calibration using the same or different method. It is to provide reliability or repeatability assurance to the customer. Retesting or recalibration of retained items. It is to ensure whatever results we have given to customer is valid. You will do one more internal test by yourself later. Correlation of results for different characteristics of an item. People in laboratory can say, if these are the input parameters, what are the likely results? You may be able to make a valid guess. So whether the results obtained is in line with that. So sometimes if one digit is made as near, one digit is added or one digit is deleted, anybody can find out. The reviewer can easily find out something must be wrong. For example, my wife, she was a qualified laboratory technician. She worked for 4 decades in a laboratory. When she got recently tested for thyroid, she got a value of 45. The usual value is less than 4.5. So initially, she suspected it could be a reporting error. Somebody has missed a digit. Okay, later it was found out it was the real value. We did 3 times the testing and we got the value 45. So the medications have to be changed. So sometimes the reviewer knows that this is an odd value what required to be done. Review of reported results. Intra-laboratory comparison as well as inter-laboratory comparison. So what is that is done? So same sample, same procedure, it will be done not only in our laboratory, similar laboratories located in our own organization, similar laboratories located elsewhere. For example, NIT may have a tie-up with IIT on a mutual agreement that some of the sample will be sent periodically to IIT lab, similar lab, and they will do the testing or calibration and produce the result. And these two results will be evaluated, analyzed for congruity. If they are similar, if the errors are well within the permissible uncertainty measurement level, then fine. In case errors are, then deeper analysis is done to find out what has gone wrong. Testing of blind samples. Okay, reporting of results. As I said, the results generated are reviewed and authorized prior to release. The probably normally the chief of the lab or a QA manager, she or he goes through the test results, test process records, and reviewers report, and then finally signs the report and releases to customer. So when we produce a result, we must ensure it is in the format in which the customer wanted it. whether all the columns have been appropriately filled up, all the details of people who have performed the testing, reviewed the report have been properly mentioned. So initially we would have agreed with the customer, these are the components of a test report, ensure all those points are mentioned. Sometimes customer will say, don't give a 2-page report, it takes a lot of time for me to read. Give me 2-line report, whether it meets the requirement or not. Detail, if required, I will ask you. You can agree upon that. You can give a simplified report to customer. However, you will retain all the data for a reasonable time, which is agreed between you and the customer. In case he wants for any investigation or a future reference, you may have to supply the data. So what a report will contain, there is a big list. I'll just go through. Title of the report, test report or calibration report or report of sampling, name and address of the laboratory, your contact references, location of performance, whether you did it here or with some service providers, and unique identification of your component, your instruments used, your reference materials used, then a name and contact information of the customer detail, identification of the method, what method you have adopted. If it is standard, you can write it. If it is your own method, you can write. You need not share all the confidential things, but you will just give a reference about the method you have used. A description, unambiguous identification of the item, what has been subjected for testing or calibration. So then historical data, like when you received the sample and when you did the sample and when you did the testing and when the report is being submitted, such details. Then when the report is being issued, if ever you have used any sample, what is the sampling plan? If it is a standard plan, sampling method, whatever you have used. And concluding statement that whatever result produced is based on what the test carried out by the sample given by the customer. The results will have appropriate units of measurement agreed between you and the customer. So in case you have taken any exceptions, deviations in the standard methods, you also will mention and why you have taken and have you got the approval of the customer for that. And people who are signing the report. These are few things which will be mentioned. Then we will come to the complaint section. As I said, in spite of your best effort to give acceptable, valid results on time to customers, it is your viewpoint. Still, customers from their view, when they look at it, there could be some deviations, feedback, gaps. So that they will periodically be communicating to you. You must have a mechanism in your organization to receive such a complaint. First thing you should do is acknowledge, whether you accept it or not, acknowledge. You have filed a complaint on that day with these details. I'm acknowledging I have received it. I'll go into details and come back to you. Then look into the detail, find out whether it is related to your testing. Sometimes it may not be related to you. Customer side, there could be issue which he may be putting it on your head. So look into that. If it is related to your area, involve the right person who is to contribute for solving the issue. Have a process in place for looking for causes, root cause analysis, identifying improvement opportunities. Improvement can be of two types. One is correction, immediately what you should do. And what should be done for preventing occurrence. If it requires reach the customer, say for example, if it is a report correction, you will do a correction in the report, resend it to customer with an apologetic remark, sorry for whatever has happened, we have done the correction, this report is valid report, kindly accept it, and we will ensure it is not happening in the future. With a remark you can send it. If it requires going to customer, getting back some instrument or gauges, again redoing it, please do that also. So depending upon what is the action required to be done, you're required to do that. And periodically monitor what is the number of complaints you have received, what are the type of complaints. So who is the person who is repeatedly doing error. So then corrective action could be training that person, providing training to that person, or changing some method. Or improving that method. So by monitoring the trend, if the complaints are coming down, it is fine. If it is increasing, then it is not a good signal. So your system must have the confidence and the courage to record all the complaints, analyze and monitor that in, and share it also periodically to the customer. What are the complaints he has given, how it has helped to improve your processes. Periodically you can have customer meet, how they are sharing the feedback has helped you to improve the process and encourage them to give further feedbacks and complaints. Okay, non-conforming work. So non-conforming is nothing but conformance is meeting all the requirement. Non-conform is whenever requirements are not met. So it's nothing but any deviation from the written down requirement. As I said, requirements are as per the standard 17,025, as per your own written down requirements from various SOPs procedures, requirements which are statutory, regulatory compliance requirement, and requirements given by customers. So any deviation from any of these requirement is considered as non-conformance. So you must have identified a person in the laboratory who will be responsible for identifying deviation, analyzing the causes of deviation, and putting corrective action in place. Okay. So responsibilities, authorities for management of NC are defined. Actions including stopping work or repeating work and withholding reports can be different type of actions. So depending upon the risk level, this person should have empowerment to do that action. So an evaluation is made whether it is significant. For example, the operating calibration room temperature, instead of 0.2 degrees permissible upper level variation, it went to 0.3. You can decide whether it is going to significantly affect the calibration activity done during that time. So if it is so, you will repeat the calibration. If it is not so, you will make a mention of it and still send it to the customer. So the evaluation is done by you, whether it is significant, whether the deviation is going to cause significantly in your results. So the decision is taken on acceptability of NC work, and customer is notified when required work is recalled. So all the deviations which are taking place, you should not feel shy to record, keep a record of it. You will give a serial number or some number which is traceable, where what has happened, when it has happened, you will give the history of the event and what were the root cause, who did the root cause analysis, what were the correction done, what was a corrective action done, what was the final action taken, whether the work was accepted with the non-conformance or it was repeated and then done, whether customer was kept informed. All that history will be kept and the management will be informed during their management review about all this progress. Control of data and information management. So we talked about confidentiality of data. One is whatever information we have, it must be usable with the least time taken for retrieval. So any data storage has to have some induction, retrieval process, ownership for the data, and access control. The access control will be decided by the lab in charge or quality manager. She or he will tell which part of the data or information management system will provide access to which are the individual. This will be periodically reviewed and only on need basis this will be given. This is to ensure confidentiality and unnecessary data getting leaked elsewhere. So you may use standard software, standard systems for maintaining information management or custom built softwares you may use. So whatever it is, you will use all these softwares validated and you will have enough safety precautions to prevent malwares, viruses. So all these will be done by the IT person, but sitting with the IT person, we must ensure all these are taken care. So minimum what protection required is unauthorized access should be protected from, and tampering and loss of data we must ensure it is safeguarded, and it should be operated in an environment it complies with the provider, or in case of non-computerized system, manual recording, transcription, storage has to be done in a proper manner for easy retrievability and proper preservation of the records. So when we have a data information system, integrity of the data management has to be ensured. Any system crash, disasters happening in information management system, they should have periodical backup or parallel data processing. So data recovery system they should ensure. whoever is running the IT system. So if it is handed over to some external service provider, all these requirements have to be doubly ensured with the external service providers also. Okay. So information doesn't mean only computer system or data generated. It also talks about the different standards, what you use, reference standards, what you use, instructions, manuals, whatever is relevant for your testing also is covered under information management system. So we are now coming to the final level management system requirement. So this particular clause is specifically for implementing ISO 17025. As I said, there are two options. One is option A, the other is option B. Option A, you require to implement all the classes because you are not already certified to ISO 9001. You are going for the ISO 17025. So every class, every subclass under 8 is applicable to you. In case you are already certified to ISO 9001, then you are exempted from certain subclasses because it is repetitive. Say, for example, policy and objective. Even in 9000, you have a requirement to have a quality policy and the quality objectives. 17025 also calls for quality policy and the quality objectives. It's not that you'll have a two different set of quality policy and objective. Quality policy will remain quality policy, whether you are auditing against 17025 or 9000. So that repetition is avoided here. Okay, so our discussion will be confining to option A, as if we are not already certified to ISO 9001. So 8.12 is talking about what are the components of management system, what are the different components we have. So it's also numbers are given 8.2, 8.3 to 8.9. 8.2 talks about management system documentation. What are the different documents you require to mandatorily develop in order to implement 17025? I have the list, it's a long list, but still we'll go through. The second is 8.3, control of management system documentation. Control is nothing but how will we ensure these documents are properly prepared, properly reviewed, properly approved, and periodically updated as and when need arises, and issue to whom copies should be given, how the obsolete copies are withdrawn and updated copies are issued whenever things are updated. All these, who is the owner for all these processes? This is addressed in 8.3. Control of records. There are two types of documents involved in all these systems. If anything tells you how to do a work, we call it a document. If something tells what has been done as an evidence, it's called a record. For example, if you are entering what are the observations you have made while doing a testing or while you are doing a calibration, those data sheets are called record. Records you cannot change. Once recorded, it will remain same. Whereas document will go on change. Today I give a set of instruction how to do a work. Then after some days I find something wrong in your working procedure. I will upgrade, I will update. So that undergoes a revision. Whenever the documents are changed, we give a different revision number, revision 1, revision 2, revision 3, like that. So the latest revision number reflects so many times it has undergone changes. So people who are using on the field, they must use only the latest revision document. Earlier document are supposed to be withdrawn from pertinent user location by the controller of all this information. Okay, actions to address risk and opportunity, we have seen about it earlier. Improvement also we have touched upon. Corrective action we have just touched upon. Internal audit, we have just mentioned about it. Management review in 8.9. So this I have told. Option B, if you are already certified to 9000, 8.2, 8.1 is not applicable. Only from 8.2 it is applicable to you. Okay. So what are the management system documentation? So as I said, the first thing is to start a policy and objectives. Any organization, not only laboratory or testing center, any organization have to have a quality policy because these standards 17025 or 9001, they are meant for satisfying customer, providing a consistent, reliable, repeatable, valid results to customer. So this talks about the quality of your process, quality of your results. So quality policy of the company has to be there. So quality policy of your company always has to address the competency of your laboratory, impartiality, consistent operation. These are the elements which have to necessarily figure in your policy. Policy is nothing but your goal of the company, aim of the organization. What do you want to do in the long run? What do you want to improve in the organization? So improvement should happen in competence, improvement should happen in maintaining impartiality, improvement should happen in consistent operation of the laboratory. So policy is not some general nice English words which are used. That should be actionable themes, what should be reflected in policy. And what is quality objectives? Whatever you have stated in policy, you must achieve it in practical terms. For example, we have talked about competency. Okay. So if you are saying in policy, upgrading competency of my laboratory personnel, if it is one of the component of policy, what would be relating objectives? So how many level 4 competent people are there in calibration center today? So how will you enhance it to a higher level? For example, 30% of the people available are level 4 competent. I'll make it as 50%. So you will have to do some training, some exposure to some other industry, some on the job training you have to give. Some activities have to follow based on the objectives. So similarly, consistent operation of the laboratory means what? The number of defects, number of errors, number of NCOs, what you produce, how will you bring it down? So your objective will be to bring down the NCs or to carry out more audits or to provide more training. So it will be actionable. So quality policy is not a slogan. It is not a good English which will remain on paper. It is translatable into performable objective. So objective always people will say it has to be a SMART based objective. What is SMART? It should be specific. It should not say I will improve quality. Quality means many things. So which part of quality you will improve? Quality of the report, quality of testing, quality of the values you will provide. When I say I will reduce defects from 5% to 3%, that is what is measurable. If I say I will reduce defect, nobody knows what it is today and what you are going to achieve tomorrow. Okay, it should be measurable. And A is for achievable. If somebody is going to say, I will have zero accident, that is how every organization says, I will have zero accidents. What is the present number of accidents? 56. So you cannot have some, utopian targets without practically not possible to achieve. What is achievable? 20% improvement, 30% itself is a breakthrough improvement. Your continual improvement processes can achieve 10 to 20%. That is what is reasonably achievable. R is reviewable. Means you should monitor periodically and then put up to top management. Am I on target or am I deviating? So this must be periodically reported to the management. If you are deviating, what is the corrective action you are doing it? What is the support you are expecting from management? And then T is time oriented. So when I said I will reduce the defectives from 30% to say 20%, by which period? By end of this year or in 2 years? There has to be a specific time period. So if a SMART element is not present in objective, it is only a slogan. So many organizations to start with, they will only have slogans. Means they just for the sake of putting some quality policy, quality objectives, they are putting it. They are not really translating into practice. When you are drawing an objective like this, for example, I will reduce defectives from 30% to 20%. Then I will go further into detail. If I have 4 testing centers, what are the defectives I am producing in 4 defective centers? In some testing center, it may be 40, it may be 20 in some, it may be 10 in some other testing center. So I will target more in 40% level testing center. I may target only 2% reduction in 10% testing center. So I will set the target to that process owner. So it must get cascaded. They must be given ownership. They must be given guideline. They must be given support. That must figure in their KRA, in their performance evaluation. So unless this cascading is done, the policy deployment or objective deployment is not effectively taking place. Okay, so policy and objectives, as I said, has to address specifically these elements: competence, impartiality, consistent operation, because this only gives confidence to your customers or legal authorities or other people. Yes, you have been working on key themes, not something unrelated. I will improve housekeeping by, instead of sweeping it 2 times, by increasing it to 3 times. I will reduce water consumption. Yes, they are all improvement, no doubt. But are they key improvements for the activities of the laboratories? To promote the confidence of your activities to your customers. Okay. So all documentation, processes, systems, records related to fulfillment of the requirement shall be included or referenced from the management system. So whatever you develop, so like I am associated with the ISO system for almost 30 plus years. So BHEL was the first company in the country to be certified in public sector for ISO 9001 in 93. So I was associated from the beginning, 93 onwards, in developing, implementing, monitoring ISO systems. So initially what we will do is, first thing what we did is we procured some new cupboards. Whatever documents we developed, we were not sharing it. We were putting it in our cupboard with lock and key. The lock and key will be always with the person in charge. For my plant SSTP, it was always with me. It was ensured that nobody takes it out, opens it, reads it and use it. So people have to depend on what I am communicating orally, but that's not the case. That's not the purpose. You may keep it under lock and key, your the master document, but some documents have to reach the people who are at a performing level. Unless they are given in letter and spirit what is written down in the procedures, they will not understand, they will not read, they will not be able to implement what is intended by the organization. So all communication must be available to them. Control, I think we have talked about it. What is the control element? Documents are approved for adequacy prior to issue by authorized personnel. As I said, any document will be prepared by someone, reviewed by somebody else who has much more experience, knowledge and competency on the system, and approval most probably by the chief of the laboratory or quality manager of the laboratory. They are periodically reviewed and updated as necessary. What is as necessary? Whenever standards are changed, you have to update. Whenever you have audit feedbacks, you may have to change it, internal audit or external audit. Similarly, whenever legal requirements change, you may have to look whether review is required. So these are all the triggers based on which you will do the review process. Changes and the current revision status of the documents are identified. As I said, whenever we change it, we necessarily give a new revision number and a date, accompanying date, so that many copies of same title are available. For example, operating a bomb calorimeter. This is the SOP's title, but you have revision 1, revision 2, revision 3. But if revision status is not mentioned in the document, you will have 3 sets of document. The individual will not know which came later, which was earlier. But if it has the revision number 1, 2, 3 and also accompanying date, clearly information is conveyed to them. The latest revision date is this one which I am supposed to use. Remaining things I am supposed to destroy it. They are all obsolete document. I am not supposed to put into use. So the relevant version, the controller of this document will ensure the relevant documents are present in the pertinent point of use. At user point, only the latest document is available. It is his responsibility to withdraw all the old document and shred it and destroy it to that extent, if it is hard copy. If it is soft copy, it is controlled by the software itself. Only the latest will be published, all other things will be withdrawn and it will be stored elsewhere under the custody of the controller. So documents are uniquely identified. By looking at the number also, we must be able to say that it is relevant to this particular department for this particular operation. If that is going to duplicate, then identification becomes irrelevant. Okay, as I said, obsolete document unintended use is prevented. by withdrawing properly and then destroying it if it is hard copy. So control of record, this addresses about how do you identify a record. Records always will be dated. Whenever you generate a data in laboratory, it will have a date. Also, who generates data, his signature and name will be there. Many times signatures are there, names are not there. We will not be able to identify by looking at signature, names are a must. Then it will have an identification, a title of the report, also an identification. Identification, normally the format number. Format also, as you know, undergoes revision. So the format uses will have a format number with revision status. Storage, what type of storage you desire, hard copy or soft copy. So how long you want to store, retention time. So how do you protect? If it is hard copy, how you are ensuring unauthorized access, where it will be kept? If it is under lock and key, who will keep the key of that storage? If it is in a soft copy, access control system will come. Archive. Archive means beyond retention time, if you still require that information to be kept for future references to build a knowledge base, knowledge management, you will take it to archive. Retrieval, if you want to retrieve any documentation, what is the index you are using? Is it date based or is it equipment wise stored or process wise? Calibration process, I do 4 type of calibration. For each type of calibration, I have 2 type of instrument. So instrument wise, date wise, I will store it, or customer wise, I will store it. So you will decide what type of indexing you will have in storing, so that the retrieval process is easier. And retention time we talked about 3 years, 2 years. Disposal of its record. At the end of it, how do you dispose? Whether you will take it to archive or you will destroy it. So this is talked in, this is the structure of documentation. There are 4-5 levels. Lab quality manual, whatever quality manual, it almost translates whatever classes, subclasses the standard tells, it will reproduce in the manual. Only it tells these requirements are done by so and so. How it is done, briefly it will describe. Lab quality manual runs from 20 pages to say 40 pages, not more than that. Procedures, this is where your SOPs, operating procedure of your equipment, the reference standard, reference procedure, software, IT control, all that is addressed. Work instruction is specifically for the people in the floor who does the testing, so it goes to him. And forms and records, these are all nothing but the reporting formats or reporting forms what they are used. All these levels are applicable for different activities, the work instruction as well as records creation. For sample receipt or purchasing activity, sampling process, testing process, record preparation, dispatch, competency development, training provision, etc. This is a long list, so I don't intend to go through the list. Mandatory means these are all specifically stated in the standard itself. I've put the reference clauses also. In those clauses, it will say you please maintain documented information on record control procedure, maintain documented information of quality policy. So like that, it talks about document and record control procedure, quality policy, competency development, externally provide services, facilities and environment procedure, equipment and calibration procedure, customer service procedure, test and calibration method procedure, QA procedure, sampling procedure, handling laboratory test or calibration item means handling and transport procedure, complaint NC corrective action procedure, reporting of test result procedure, calibration report and certificate requirement procedure. Then records, if you look at a list of internal and external documents, list of type of records, registry of records for detention and central archives, quality objectives, training programs, training record, record of attendance, competency approval and authorization record, supplier evaluation and approval record, list of approved suppliers of products and services, record of laboratory environment controls, list of laboratory equipment. I will leave these similar records it is asking for. And it is also recommended, though it is not mentioned as mandatory record, some records like this are supposed to be key records. It is suggested, though not mandatory, you may keep it if you want to implement ISO 17025. addressing risk and opportunity, report of customer satisfaction. It is not customer complaint. Periodically, you evaluate a customer not related to contract. Generally, go to him and find out how happy he is on quality, service, delivery, competency of people, our responsiveness, our processes, compared to competitor, how well we are performing, where customer thinks we require to improve. This is an improvement activity. Internal audit procedure, though a procedure is not called for in detail mandatorily, having a procedure helps. Similarly, management review procedure. So 8.5 we have touched upon addressing risk and opportunities. We have just mentioned about it earlier. I will leave it. Improvement also, like opportunities for improvement, triggers are from audits, from customers, from accreditation bodies, statutory authorities. So all those people we get it from top management sometimes, from benchmarking by looking at other organizations we get improvement opportunities. So NCN corrective action we briefly touched. I will not go into detail. Internal audit, though there is no time specified, most organizations prefer at least once in 6 months. So it's always more frequent, more deviations you will bring down at the earlier point, and resolving is helpful to the organization. So audit program is nothing but audit schedule. Audit is done by trained internal auditors who are trained on ISO 17025 standards and audit skills. Auditing requirements are given in ISO 19011 standard. These two are taught to internal auditors on a 2-day or 3-day program. The trained auditors will do the audit in organizations and provide a report based on which corrective actions are taken. The outcome of these internal audits are reported both to the top management as well as to the external auditors. So what are the 3 types of audits normally? One is witnessing. When somebody is doing a testing, just looking at how well he is following the procedure, doing the testing, recording the observation, reporting the result. It is called witnessing the testing or auditing. It's applicable even for ISO 17025 external auditors. When people like me, when we are going on audit activities, once in a while there is an accreditation body in Europe. They come and witness how well we do the audit in our own presence, and then they give a report and points for improvement. It is to ensure the audit process is robust and taking care of all the points. Vertical audit is nothing but how the process is successfully run through the system. They'll take one simple report, what is given to a customer. They will either trace backward from material procurement, equipment, whatever equipments used, from equipment procurement, engaging people, do they have competence, engaging external service provider, have they gone through the procedure, what is their rating, what were the SOPs designated, whether they were followed, all your records are in good shape without omissions. So entire sequence of activities from beginning to end will be verified. That is vertical audit. Horizontal audit is taking a process, for example, competency process. If I take competency process, I will take a competency records of all the people in the laboratory. Okay, or I may take one particular calibration process. Who are all engaged in calibration process, I will take them. So what is the competency defined in the procedure? What is the evaluation done on all these people? What is the finding, gaps were found or not? So for the filling up of gap, what were the programs conducted, training program or not? What were the evaluation result? What is the reason rating given to them? And level has it been assessed for them? Level assigned and level available to the people, is it okay? So one particular process across the organization, if you are doing, it is horizontal audit. So external, internal audit can be done either in vertical mode or in horizontal mode. It is left to the choice of auditors. There is no particular method. Management review, almost end. Management review, as I said, is very, very critical point. This is where the top management is appraised. The organization's top management, not lab's top management, organization's top management is appraised on how the activities are being carried out with respect to testing and calibration. So their decisions are obtained after the review and the decisions are recorded for further implementation. The standard very clearly defines what are the necessary agenda points we have to cover. Also, how the decisions have to be reflected. So you have no choice. You can add something more, but you cannot omit any of these things. If you omit any of these things, you can be found as a deviator, and the standard issuing certifying authority can take exception to that. Okay. So what are the things? One is a change in internal and external issues that are relevant to the laboratory. So this we have not discussed much on that. So context of the organization, that point we have not touched. So what are issues which can affect your laboratory organization? External issues means, I'll just touch an example. Legal changes. For example, you may be using benzene in your chemical laboratory today. Government may bring a rule, benzene is banned for use in any laboratory also. So definitely that you cannot do any testing related to benzene. You have to go for alternative material. Till that time, you cannot perform the test. So it affects. So any legal development, any development in competitor, any development in your customer, which will change your process of doing your activity. Internally, some people have quit your organization. So area in which they were operating becomes with lesser manpower. You have to recruit manpower. Okay, it is talking about competency, culture, such issues related to internal. Okay. Fulfillment of objectives. What are the objectives you have set for the organization, whether you have met or not? Suitability of policies and procedure. Because of development in external area, policies and legal developments, do you have to change your policy or can it remain same? Status of action from previous management reviews. Previous review, what all we have accepted to do, how much we have done. Okay, outcome of recent internal audit. Corrective action, what is the status? Identified corrective action. What is the committed dates? Has it been completed or not? Assessment by external bodies, mainly the certification audit and any other audit if you have undergone. Changes in the volume and type of work or in the range of laboratory activities if you have got a change. Customer and personal feedback, customer satisfaction report if you have any, or customer complaint status. Effectiveness of implemented improvement. Whatever you think you have improved, is it remaining same or do you have problems? If it is recurring, the improvements are not effective. Adequacy of resources. Do you require any support from top management for more training or for providing better equipment or instrument? What are the support you require from top management? Results of risk identification. What were top risks you have identified? What are the mitigation plan you have put? Are the plans getting implemented? Do you have any issues on that? Outcome of the assurance of validity of results. Are they in order or do you have any issues? Other relevant factors such as monitoring activities, training, feedback from monitoring activities, like you are monitoring various parameters. Simple examples are laboratory environment. Are you able to meet the requirements? Do you have issues? So all these are all defined agenda points for management review, which you necessarily have to discuss. Outputs, how do you record the decisions? Effectiveness of the management system and its process. Whatever verdict people have given from top management, you require to record. Improvement of the laboratory activities related to the fulfillment of the customer requirements or requirements of this document. Provision of required resources. What is the resources they are going to permit? Any need for change in the policy, change in the system, change in the processes, all that you will record as an outcome. So what are the key benefits? Say professional working approach. Implementing the standard will enable a hierarchical order. We have seen preparation by somebody, review by somebody, approval by somebody. There is some lab in charge, there is a technical manager. So there is a clear hierarchy, clear job responsibilities are defined. Established procedures will be followed, policies will be followed, work rules will be followed. As a result, internal company management will become more effective, achievable. It will also reduce over a period errors, what is happening because of risk management, what is it you are doing. Reliable laboratory and customer relations. This gives a very higher focus on helping meeting customers' requirement. We have talked about customer requirement almost in every level. So this is supposed to improve customer relation. The client has a trusted business relationship when laboratory is committed to confidentiality. So that will give lot of confidence to the customer. So also we give option to customer whenever he wants to give feedback, whenever he wants to give about his satisfaction, we give an option to express and we are taking it seriously. Not only we resolve customer complaints, we also periodically will arrange customer meets to share, thank them for providing such feedback. And we are demonstrating competence by periodically reviewing and improving. And it is a iterative process of management. It is not just a set process. We are periodically reviewing, looking for deviation, looking for opportunity for improvement and improving the processes. Validity of final report goes through a iterative process and highly reliable information we are giving. Conformity with testing trends. Whatever happening around the world, we are learning from them through benchmarking process and confirming with whatever is the trend of the day. These are the benefits. Thanks for your patience. It was a long session and it is not easy to read through the testings, test standard, the ISO 17025 standard and understand. Still, I thought by removing as much as possible the terminology of standard, I've tried to convey something. My contacts are available with the NIT departments. I welcome people to raise queries, ask clarifications through mail or through my phone number. I'm sure I'll be able to respond to you either over phone or through mails. Thank you once again for your participation and patience to the session. Thank you.
Thank you, sir. Thank you very much for your wonderful session.